Hello, my name is Gaurav Kumar and I had just completed my M.Tech from IIT Delhi. In the previous video, we have seen the real life example of Thevenin's theorem. Now we are going to handle the question related to Thevenin's theorem. So you are all aware that the practical voltage source in this figure you can see that the practical voltage source is there, and this can be replaced by a equivalent voltage and equivalent resistance. Equivalent voltage means open circuit voltage where current will be zero, and equivalent resistance means it depends on the behavior of network. Why this depend on the behavior of network? Because if independent source is there and as well as dependent source are also there in the circuit, so in independent source, if independent source is there, then voltage source will be replaced by a short circuited and current source will be replaced by a open circuited. So this is understandable or not? I again repeated that if the independent source is there, just like the voltage source and current source, so voltage source replaced by short circuited and current source will be replaced by open circuited. Okay, and and when the problem arises, when the dependent source is given, then we replace the circuit by VDC and IDC. We will see in the next slide. The voltage in this voltage source are there, then it is replaced by a short circuited, and current source is there, then it is replaced by a open circuited. Okay, so in this manner we have to find RTH, equivalent resistance, and equivalent voltage source. So now we are going to tackle the question related to gate examinations. So in this question given that for the circuit shown the Thevenin's voltage and resistance looking into XYR. This is the XY. I have forgotten to write in this circuit diagram. So don't worry. Assume X and this node is Y, X and Y, and VTH is between X and Y potentials. So the question is asked that what is the Thevenin's voltage and resistance looking into XY. We have to find Thevenin's voltage and Thevenin's resistance. So in this we can VTH is there. So if we have the voltage of a circuit, so VTH is in this node, and voltage source this potential and this potential are same. So open circuit voltage are the same in this node, and open circuit voltage are similarly in this node and similarly in this node. But 1 ohm resistance is there, so in this node voltage source is different. So in this solution where you can see that VTH is there, so same voltage VTH is also there, and the open circuit voltage means current will be zero, so we are taking 0 ampere as the current source which are going from this node to this node. This is the open circuit current. So we have to find VTH. So how can we find the VTH? Just take in this area the I is given, so I is equal to VTH by 1. I is equal to VTH by 1 is equal to I into I is equal to VTH. Apply KCL in this circuit. So VTH minus 2I divided by 1, VTH divided by 1, VTH and sorry minus 2 ampere is the incoming current, and VTH by 2, and 0 ampere is the incoming current. So we simply write the KCL, and when you solve the KCL, the current we are in this result, the current is equal to I is equal to VTH in the previous, and when you going to solve this equation, you find that VTH is equal to 4 volt, and VTH is equal to 4 volt is the answer of our questions. So now coming to the next question. This question are also asked by IIT in 2017, I think. In this question ask about what is the Thevenin's voltage and Thevenin's resistance between the A and B node, between the A and B. So we have to replace A and B. RL is removing, and open circuit we have to replace RL into voltage open circuited. Okay, so you can see in the is upcoming slide. So for this, BTS is open circuited voltage and 0 ampere. Due to the voltage open circuited, the current will be 0, so 0 ampere. And I and this I is current is given or not? Just a minute. Yes, I is current is there in the question. I current is there, so I is moving into this loop. I is moving into this loop, and this loop 0 ampere is given, so I current is moving into the 1 ohm resistance and 2 bs resistance also. This whole loop. Okay. So as I said earlier, I is currently moving to this loop and this loop. So VTH and 2I, if you apply the KVL, so minus VTH plus 2I plus I plus 2bs is equal to 0. So VTH is equal to 3I plus 2bs. Assume this is equation number 1 and apply KVL in this loop, so minus bs plus 1 I into 1 plus I into 1 plus 2bs. Okay, apply simply this KVL in this loop. So we find I is equal to minus bs by 2. If I is equal to minus bs by 2 and we put the bs by 2 into this first equation, we find that 3 into minus bs by 2, I is equal to minus bs by 2. So BT is equal to bs by 2 is the answer of my question. And for RAB, the equivalent from A to B replaced by a BAB, because BAB and IAB is the current. Okay, one second. Dependent source are there. Dependent source are there in the questions. Here, this dependent source I current is there. That's why we take voltage of BAB and IAB in the circuit, and if you solve, apply KVL in this loop and apply KVL in this loop. So we have find two equation in this circuit. In the first loop, 2I, one second, 2I plus IAB and IA plus IAB into 1 plus minus BAB. If you solve this equation, then BAB is equal to 3I plus 2 IAB. Apply KVL in loop 1. In loop 1, I plus IAB and II. Okay, and I. So 2I plus IAB. One second. 2I plus IAB. So 2I is equal to minus IAB and I is equal to minus IAB by 2. So put this value in equation 1. If we put this value in equation 1, BAB is equal to 2 IAB plus 3I minus IAB by 2. So BAB is equal to IAB by 2, and come to the denominator part. BAB by IAB is equal to RTH and RTH is equal to 1 by 2 is the answer. Why is it called BAB? If you apply the Ohm's law, B is equal to IR and B by I is equal to R. So that's why it's called as the equivalent resistance, and equivalent resistance value is 1 by 2. Come to the next part. In the circuit shown below, if the source voltage Vs is equal to 153.13 volt, and then the voltage of the Thevenin as seen by the load resistance RL. Thevenin's voltage seen by the load resistance RL. So in this we applied the Thevenin's theorem. So we have to draw the circuit. Firstly, draw the circuit diagram and find where I can use this formula of Thevenin's theorem to find the VTH. And when the VTH, once again, VTH, and in this we have to find the VTH 0 volt due to the I2 is short circuited. Why I2 is short circuited? Just hold a minute. Okay, okay. Because of open circuit voltage, if you apply the voltage source, then the open circuit voltage is there and the current will be zero. That's why J40 I2 is there. So I2 is equal to 0 ampere. I2 is equal to 0 ampere means the whole voltage is equal to 0. So if you find the BTS is equal to BOC. I2 is equal to 0. VOC means open circuit voltage, and BTS is equal to 10 VL1, because in all this circuit and the inductor columns, the current will be 0, so voltage will be 0. Voltage will be 0. So VL1, if we find the VL1, then we have to find the BTS value. So firstly find the VL1 value. How can I find the VL1 value? This BL1 is equal to BS into J4 divided by J4 plus J3 with the help of voltage divider rule. So we can written that BL1 is equal to BS into J4 3 plus J4. So BL1 is equal to 80 angle 90 degree. So we find VL1. So now BTS is equal to 10 VL1. So if you put this value VL1 in BTS, so 10 into 8, 80 angle 90 degree. So BTS is equal to 800 volt is the answer of the questions. Now coming to the next questions of gate, the Thevenin's voltage VTH seen from the terminal AB. We have to find VTH. So we can assume that I2 is equal to 0. In this I is equal to 0, and the same voltage is appearing on this node, and BA1, we assume that in this node the voltage is BA. Okay, apply KCL at node 1. In this we have to apply KCL. So BA minus 2 volt by 1, BA by 1, and this is the super mesh condition, super node condition. That's why this is neglected, and BTS by 2, and this incoming current is 0. So take 0 is important. So we have already told that BA minus 2 by 1, BA by 1, BTS by 2. This, if you solve this, then BTS plus 4 VA is equal to 4, and apply KCL at node 2. No, not node 2, basic KVL apply in the node 2. So BTH plus sign is there, so BTH is plus, and minus BA1 is equal to 20I. This is the potential difference between the two nodes. BTH plus BTH minus BA1 is equal to 20I. I once again repeated that this is the potential difference between BTH minus BA1 is equal to 20I. And we can write BA by 1 is equal to I. How can I write? Because if you apply the KCL, so BA by 1 is equal to I. So we can write that like that, BA by 1 is equal to I. So BA is equal to I. Put this value in equation 2, we get BTS is equal to 20 BA plus BA 21 BA. Okay. So if you apply the BTS value in equation 1, so 21 BA plus 4 BA is equal to 4, so 25 BA is equal to 4, so BA is equal to 4 by 25. We find the VA value. Now we have to find the BTS value very easily, because